Hi Ram to all. Here in this presentation we are going to solve the questions of exercise 10.3. I hope that you have solved the questions from exercise 10.1 and 10.2, and simultaneously you have to solve the questions of exercise miscellaneous exercise. Then let us start some questions of exercise 10.3. Question number first, we have reduced the following equation into slope intercept form. If you are remembering, in the previous presentation we have learned the concept of slope intercept form and different forms of straight lines. And the slope intercept form, the we know y is equal to mx plus c, where m is the slope and c is the intercept on the y axis. Then let us reduce this. Three parts are given. I am going to solve the first part here. And if you are considering the first one, the equation is given to you, x plus 3y equal to 0. Then this is written as y is equal to minus 1 upon 7x plus 0. And if you are comparing with the equation slope intercept form, y intercept form, this is y is equal to mx plus c. Then clearly we are observing the slope, we are getting m equal to minus 1 by 7, and the intercept we are getting as y intercept we are getting as 0. Here we have question number second, and in this question, reduce the following equation into intercept form and their intercept on the axes. Then the intercept form, we know x upon a plus y upon b is equal to 1, where a is intercept on the x-axis and y is intercept on the and b is intercept on the y-axis. Then let us reduce this. And here also I am going to solve the first part out of these three. The equation is given to you, 3x plus 2y minus 12 equal to 0. Then let us reduce this. If you are taking 12 on the other side, then we are getting 3x plus 2y equal to 12. And if you are dividing all these three values by 12, then we are getting the required form as x upon 4 plus y upon 6 is equal to 1. And if you are comparing with the equation x upon a plus y upon b is equal to 1, this is the intercept form of a straight line having intercept a on the x-axis and b on the y-axis. Then clearly we are getting the value of a and b as 4 and 6. Question number third, we have to reduce the equation into normal form, and also we have to tell the perpendicular distance from the origin and the angle between perpendicular and the positive x-axis. We have to first reduce this into normal form, then we have to tell the perpendicular distance from the origin and the angle between the perpendicular. Then here also I am going to solve part first, x minus root 3y plus 8 equal to 0. Then let us do this. If you are considering the equation as x minus root 3y plus 8 equal to 0, then if you are reducing, then we are taking 8 on the other side, we are getting minus 8, and distance cannot be negative. For this reason we are multiplying both sides by minus sign. Then we are getting the reduced equation as minus x plus root 3y is equal to 8. And if you are dividing both sides by under root a square plus b square, here if you are observing, a is coefficient of x and b is coefficient of y, and if you are using the concept under root a square plus b square, and if you are dividing all these value by this, then the value of under root a square plus b square we are getting as 2, and on dividing all these value by 2 we are getting minus x upon 2 plus root 3 upon 2y is equal to 8 upon 2. Then on solving we are getting the reduced equation as minus 1 by 2x plus root 3 upon 2y is equal to 4. Minus 1 upon 2 is written as cos 120 degree, and root 3 by 2 is the value of sine 120 degree. Then this is the required normal form, x cos 120 degree plus y sine 120 degree is equal to 4. And if you are comparing with the equation x cos omega plus y sine omega is equal to p, this is a normal form of the equation, then clearly we are able to tell the perpendicular distance we are getting p as 4, and omega we are getting, the angle we are getting as 120 degree. Perpendicular distance is 4 and the angle with the positive direction of x-axis we are getting 120 degree. Question number 4 we have to find the distance of the point minus 1 1 from the line. In the formula we know, if we have to find the distance between the point and the line, then the distance formula we have for finding the perpendicular distance here. Then let us do this. If you are reducing this given equation in the form ax plus by plus c equal to 0, then we are getting 12x minus 5y plus 82 equal to 0. And if you are comparing with the general equation of straight line ax plus by plus c equal to 0, we are getting the value of a, b and c. A clearly we are observing 12, b is minus 5 and c we are getting 82. Now we have the value of a, b and c. Then let us use the distance formula. Then the distance formula we know, distance of a line from a point, then d, small d is equal to ax1 plus by1 plus c upon under root a square plus b square, where x1 y1 is the coordinate of the given point from which we have to find the distance. Then this is given minus 1 1. Then let us put all the values of a, b and c we have. If you are putting the value of a, b and c, we are getting 12 minus 5 82, and the values of x1 y1 is minus 1 1. On putting all these values and on solving, we are getting the required distance. Next question we have to find the angle between the given two line. These two equations are given, root 3x plus y equal to 1 and x plus root 3y is equal to 1, and we have to find the angle between these two lines. For finding the angle we have the formula tan theta is equal to m2 minus m1 upon 1 plus m1 into m2. Means we need the slope, and if the equation of a line is given, then in the previous presentation only we are able to tell the value by using the concept minus a upon b. Slope is equal to minus a upon b, where a is coefficient of x and b is coefficient of y. Then here for the first equation we are getting minus root 3, and for the second equation we are getting minus 1 upon root 3. And if we have the slope, then by using the formula tan theta is equal to m2 minus m1 upon 1 plus m1 into m2, easily we are getting the angle between that two line, the given two line. Then let us find the slope first. If you are reducing this equation in the slope intercept form, then we are getting the slope as minus root 3 and minus 1 upon root 3, or you may find the slope by observing the equation. Then we have the formula, and if you are putting the values of the slope m1 and m2 in the given formula and on solving, we are getting tan theta is equal to minus 2 upon this, means tan theta is equal to 1 upon root 3, and this is the value of tan 30 degree 1 upon root 3. Therefore the angle between the given two lines we are getting here, either it is 30 degree or it is 150 degree, because we are getting the value as plus minus. If you are getting here 1 upon root 3, it means that this value is plus minus root 3, and if you are considering plus 1 upon root 3, then we are getting the angle as 30 degree, and if you are considering minus 1 upon root 3, then we are getting 150 degree. Similarly we have to solve the questions. Sai Ram to all.